All right, let's jump right into this explainer. We're looking at a staggering cosmic mystery today. How exactly the sun uses mass to power our entire world. We look up, we feel the warmth, and we kind of take it for granted. But the actual nuts and bolts of how the sun pumps out that mind-boggling amount of energy, that baffled humanity for centuries. So we're going to unpack that today. We'll break down the sheer scale of our star's power and the hidden mechanics that make the whole shebang possible.
To really wrap your head around the scale here, consider this number: 600 million. Every single second, the sun is hard at work converting 600 million tons of hydrogen into helium. Just to put that into perspective, that's roughly the weight of 1,500 Empire State Buildings changing form in the literal blink of an eye. But here's where the story gets a little weird. Scientists realized that when you measure the resulting helium, it actually weighs slightly less than the original hydrogen did. A tiny fraction of that 600 million tons, it just vanishes during the process.
Which of course begs the ultimate question. Where does the missing mass go? Based on the strict everyday laws of physics we interact with, things don't just pull a disappearing act into thin air, right? You can't just lose millions of tons of matter without a trace. It's not lost, and it's not misplaced. But to solve the riddle of where it actually goes, we gotta step away from the sun for a second and take a quick trip back in time to an unassuming little office in Switzerland.
So Section 1, the patent clerk's key. Let's talk about 1905, the miracle year.
Because, amazingly enough, the answer to our massive solar mystery didn't come from some astronomer squinting through a giant telescope. It came from a 26-year-old patent clerk named Albert Einstein. He wasn't working in some fancy university lab. He was literally just reviewing everyday inventions for his day job. But in his spare time, he was quietly rewriting the fundamental laws of reality. In just a few months during 1905, he dropped a series of revolutionary papers. Early in the year, he explained the photoelectric effect. By mid-year, he introduced special relativity. And then, late in 1905, he published a paper containing just 5 symbols that perfectly solve our sun's missing mass problem. It would go on to be the most famous equation ever written.
Moving on to Section 2, decoding the equation, the math behind starlight.
Okay, we've all seen this beautifully simple equation before, E equals mc squared. But let's really break it down. E stands for energy, M stands for mass, and c is the speed of light, which is an incredibly fast 299,792,458 meters per second. That's almost 300 million meters every single second. What Einstein was revealing here is an absolute game changer. Energy and mass, they aren't totally separate things at all. They're intimately linked together by the speed of light.
But the real secret sauce lies in the sheer, mind-bending scale of the math. Einstein didn't just multiply mass by the speed of light, he squared the speed of light. Imagine putting $1 in the bank, and instead of doubling, it multiplies by 90 quadrillion. Yeah, 90 quadrillion. Because c is squared, we're multiplying a mass by that massive 90 quadrillion figure. That multiplier is so astronomically huge, it completely flips how we have to think about ordinary, everyday objects.
So what does that math actually mean in the real world? Well, it means that even a tiny, seemingly insignificant speck of matter contains a genuinely unbelievable amount of energy. Take a 1-gram paperclip. If you could perfectly convert all the mass inside that single tiny paperclip into pure energy, it holds enough hidden power to run an entire city. For context here, the bomb that destroyed Hiroshima, that converted less than a single gram of mass into energy. Basically, mass is just frozen energy, tightly packed and waiting to be unleashed.
Which brings us to Section 3, the solar mechanic, and solving the sun's missing mass.
Now, fortunately for us, nature rarely allows a total 100% conversion of an object like a paperclip all at once. But in the intense, extreme heat of the sun, tiny fractions of mass vanish constantly through a process called nuclear fusion. When hydrogen fuses into that slightly lighter helium we mentioned earlier, a mass defect happens, and boom, E equals mc squared kicks in. That tiny fraction of missing weight, it didn't vanish into nothingness. It became the brilliant energy powering our entire solar system. The sun is literally shining by turning its missing mass directly into the sunlight that radiates outward through the vacuum of space. And just think about the incredible chain reaction that missing mass sets off. That energy takes an 8-minute road trip through space before it finally hits Earth. It creates every sunrise we see. It powers our modern solar panels. It provides the energy that grows every single plant and every forest on the globe. The big takeaway here is this. Every time you step outside and feel the warmth of the sun on your skin, you are literally feeling mass that vanished from the sun 8 minutes ago, transformed perfectly into the energy that makes all life on Earth possible. It's wild.
All right, moving on to Section 4, Earthly Applications, and how we're mimicking the sun. So the sun has been fusing atoms naturally for billions of years. But eventually, humanity figured out how to harness this exact same principle of mass conversion right here on Earth through a process called nuclear fission. Instead of smashing atoms together like the sun does, we force heavy atoms to split apart. This action leaves us with lighter atoms, but once again, we get missing mass. And just like in the sun, that tiny bit of missing mass converts into an enormous, explosive release of energy. It's the exact same principle that safely powers massive electrical nuclear reactors on the grid today, but tragically, it's also what powered the very first atomic bombs.
Now, to be clear, Einstein himself didn't build those weapons, and he actually expressed deep regret over how the technology was ultimately used. But as he noted, his equation wasn't dangerous on its own. It simply described nature. E equals mc squared is a completely neutral mathematical truth about how the universe operates. It just pulled back the curtain on a fundamental law and basically left humanity with the profound, heavy responsibility of deciding exactly how to use that kind of immense power.
But hey, it's not all just power plants and weapons. These applications are woven into our everyday lives in ways you might not realize. Without Einstein's theories of relativity, the GPS satellites your smartphone uses, they wouldn't even work. Your location would drift by several kilometers every single day. Life-saving medical PET scanners rely directly on matter converting into energy to let doctors peer inside the human body. And zooming out to a cosmic scale, these principles dictate how black holes shape the very fabric of space-time. This equation is quietly humming away all around us all the time.
Which brings us to Section 5, the frozen energy universe, and our grand conclusion.
The ultimate lesson from Einstein's magnificent discovery goes so far beyond just the mechanics of stars or the electrical grid or the devastation of weapons. It really speaks to the very nature of existence itself. Matter is frozen energy. Literally everything around you right now, the chair you're sitting on, the screen you're staring at, the air you're breathing, the mountains, the oceans, even your own physical body is essentially just energy wearing the disguise of matter. Matter isn't fundamentally separate from energy at all.
They are simply two faces of the exact same reality. And honestly, that forever changes our understanding of a universe that turns out to be far stranger and far more beautiful than anyone ever imagined. So, as we wrap up this explainer, I want to leave you with one final mind-bending thought. If you, and literally everything you love, are simply made of frozen energy, how does that change the way you see your place in the universe?